Azure Synapse Analytics is a comprehensive and unified platform for all your analytical needs. Whether you are building a modern data warehouse, a big data solution, or aiming to combine these two capabilities to build lakehouse architecture. Azure Synapse has all the capabilities in a single comprehensive service for your end-to-end needs. Welcome to Ask Trailblazers. I'm Arshad Ali, and in this video, I'm going to introduce you to Spark Pool for building big data solutions. Spark Pool is based on Apache Spark. As we all know, Apache Spark has become a de facto standard for big data processing and advanced analytics. Before we get into details, let's quickly review Azure Synapse Analytics architecture and different components in its ecosystem. On the bottom, as you can see, we have data lake storage, which is optimized for analytical workloads. Through data integration layer, different analytical runtime engines connect to this data lake storage. And based on your requirement, you can choose, or better yet, mix and match these runtime engines for all types of your analytical use cases. You can choose SQL Pool for building modern data warehouse, Spark Pool for building big data processing engine, and newly introduced Data Explorer to unlock insights from log and telemetry data. Azure Synapse Analytics is an enterprise-ready service and provides all the enterprise-grade capabilities. For example, monitoring, multiple layer of security along with native integration with Azure Active Directory for single sign-on experience, management and data governance, etc. Let's get started with the Spark Pool. Here I am in the Azure Portal, and I have opened my Synapse workspace. If you are new to Synapse, you can refer my video titles Azure Synapse Analytics Introduction and Getting It Started to learn about Azure Synapse and a step-by-step guide on how to create Synapse workspace. For now, I have this Synapse workspace already created, and on this overview page, you see a list of all type of analytical engine that we can create. This is something that you can see on the top of this overview page. If you can scroll down, you'll see all types of analytical engines pools created. So for example, SQL pool, and you'll see there is a built-in SQL pool, a pool for serverless query execution, and then I have one dedicated SQL pool created. Likewise, I have a couple of Spark pool created over here, and there is one for Data Explorer pool. So this is a place where you can have a look at what all type of analytical runtime engines pools have been created. And if you want to create a new one, you can click on any of this link based on what type of pool that you want to create. For now, let's go ahead and start creating an Apache Spark pool. To do that, I'm going to click on this new icon over here and going to specify the different parameters for this pool. So the first thing first is we have to specify the name for the pool. I'll say Spark Pool version 3.1, right? And the next option is to kind of isolate compute. Isolate compute is a very unique feature to Synapse where you can segregate your compute completely from different customers' workload. This feature is only available in some of the regions, and it's only going to be applicable if you are using larger node size. But this helps in a scenario where you want to have completely isolated compute environment. So that is a feature that's available here. I'm going to kind of click on disable for now because I want to create a small size node for my Spark cluster. And then the next one is the node size. So the node size is going to be small, medium, large, extra large, and double XL in this case. Based on when you are kind of creating this Spark pool, this might have another options, but for now these are the options available. So let me go ahead and click on small for now. A small node comes with 4 vCore and 32 gigs of memory, and then for auto scale I'm going to say disabled, and going to specify a specific number of nodes that I want for this Spark pool. You can have auto scaling set where you can say minimum number of nodes and maximum number of node, and your Spark cluster, when it gets provisioned will be provisioned with the minimum number of nodes and can scale up to the maximum number of nodes as you have specified. Let me show that to you also. So if you click on this enable, you can specify the minimum number of nodes. For example, if I say 10 and I say I want to start with 10 and I want this cluster to kind of scale up to 20 nodes, right? So when you start executing your queries or processing logic against this Spark pool, the initial size of the cluster that gets created is with 10 nodes, and that can scale up to 20 nodes based on the workload getting executed, right? So this is the auto scale setting. I'll keep it disabled for now, and this is the estimated cost for the cluster size that I have chosen. This is going to give us a per hour cost, roughly per hour cost. This is based on the retail pricing that we have for Azure Synapse Spark pool. And what very important thing with Spark or Azure Synapse in general is anyone executing the code, whether it's a SQL script or a Spark script, and accessing the data from data lake storage, that individual's ID or credential is getting passed through to the storage account and getting validated if that individual has access to the storage account or not, right? So in order for one individual to have access on the data, that individual needs to be part of storage block data contributor role on the data lake storage account, from where that individual is going to be accessing the data. He or she needs to be part of this contributor role over there. So when we are executing notebook interactively in the Synapse Studio, it uses individual's credential and passes it through to our data lake storage account. When we schedule that notebook and run it through pipeline, the MSI of the workspace is being used to get authenticated against the data lake storage account, right? So this is my initial configuration on the basic tab of new Apache Spark pool creation wizard. Let me go to the next page and look at the other details. So on the next page of this wizard, additional settings, we have options to choose whether we want to have automatic pausing of the cluster that's getting created when we are submitting the job. And here again we have options to enable and disable it. I want to keep it enabled so that when the cluster is not being used or the hardware resources are not being used for 15 minutes, that gets deallocated and we stop paying for that compute resources, right? So this is very important to save on the cost, right? So we'll keep it enabled and we'll keep it default 15 minutes for now. The next one is the Apache Spark version, right? So we have two choices over here at this point of time. We have 2.4, Apache Spark 2.4, and then we have 3.1. So I'll go with the most recent version, 3.1. And this 3.1 version comes with different libraries and a language, and each of them has their own version, right? So Python is 3.8 with this 3.1 Apache Spark. Likewise, if you look at Delta Lake, it's going to be version 1 with 3.1. And the next option is to specify the Spark configuration. So in many of the cases, you do not need to change the Spark configuration. The default configuration that comes with the base image or the cluster, when the cluster gets created, will be sufficient. But in some cases, when you want to change the configuration, Spark configuration, you can create a file where you can specify configuration type that you want to change and the respective value for it. And this file looks something like this. So here if you see, I have this one configuration for a Spark. I'm saying a spark.driver.max result set is equal to 10 gig and this is the value that I want to set it to. Likewise for executor, I'm saying 4 gig. So each of the executor is going to have 4 gigs of memory. And then each of the executor is going to on this Spark cluster there will be 4 instances of the executor, and each of this executor will have 2 cores, right? So this is the kind of configuration. If required, you can change it and you can create a text file and upload this text file here at a Spark pool level. As well as when you are executing a notebook, during that time also you can change this configuration, and I'll show you some of the examples of that. The next option is to kind of specify the package that you want to get it installed when the Spark cluster is coming up. So Spark cluster has already pre-installed packages which we'll be using most of the time, but in case if you want to install some custom packages or some packages which are not pre-installed, we can do that. And I'll talk in detail about how we manage the library and how we install these packages in future video, but that is an option available over here. The next one is intelligent caching, and this is very interesting feature with Synapse Spark pool. So when we read files which is sitting into a remote storage location, every time when we are reading the files, there is a remote call to get the data from the remote storage account, in this case data lake storage account. The Spark allows us to cache that data in memory, and we can explicitly do that, right? So when we kind of read a file and we are going to be using that data repetitively, we can cache that data and can use it in memory. So that's a very good feature. That's something that we can use. However, the challenge here is over a period of time, the number of files that we have read or even the data in those files get kind of updated. So the cache is kind of stale. So in that case, we need to invalidate cache and go back again and pick up the new data, right? So that is something, a manual overhead that we have to do. With intelligent cache, we can just specify we want to use this feature and how much kind of percentage of a storage that we want to use on each of the storage node, whatever is the storage available on that specific node minus storage for shuffle data. That's the total amount of storage that we can use it for intelligent caching, and what percentage of that storage we want to use for intelligent caching. So this is just a configuration change that we have to specify, and a Spark pool in Synapse is optimized to take advantage of this intelligent caching, right? So this is very nice feature or nice addition to a Spark pool in Synapse. The next page of this wizard is where you can specify a tag of name and value that will allow you to categorize your resources so that you can see a consolidated billing of all the resource consumption. This comes very handy in a scenario where you have multiple application and you want to see what's the consumption, Azure resource consumption for each of those applications. So you can tag those resources based on different type of application, and based on those tag, it's like a logical grouping, and based on those tag you can see what's the consumption for that specific set of application or services utilized by that application. So this is tagging that you can do over here. And the next page is where you can review all your details that we have provided over here, and click on create, and it's going to create the Spark pool. The one thing that we have to note over here is we just have provided the details for the Spark pool. It's just a metadata that gets saved about that Spark pool. At this time there is no hardware allocated, so it also means that when we create a Spark pool, we are not paying for the hardware resources, or we are not paying for any consumption at this point in time. When we start submitting a job against this Spark pool, that is when a Spark cluster gets created, and and the code that we submit starts getting executed. So this is what we can do in Azure Portal. Let me go back again here and look at some of the details for this Spark pool that we just created, right? So there are a few parameters that you can change even after creation of this Spark pool, and the very first one is the scale setting, right? So this is the scale setting that we initially provided when we created the Spark pool, but we can also change it later if we want to, right? So we disabled auto scaling earlier. If we want to enable it, we can go ahead and enable it and specify minimum number of node and maximum number of node, and it's going to kind of have that new setting set for the future cluster getting created, right? So I'll keep it disabled, and again all those settings are over here. The one thing that you will notice over here is force new setting. So this is something that you have to check when there is already an active connection on one of the cluster or the cluster created from this Spark pool, and you want to force these changes by killing those connection and applying those settings immediately. So you have to check this option and say apply. At that time all connection will be terminated and the settings will be applied immediately. Or you can apply this setting without checking this option. In that case, these settings will be applicable when the new clusters are getting provisioned from the Spark pool, right? So this is a scale setting that we can do over here. Let me kind of close this for now. Likewise, we have this pause setting, right? So we kind of selected auto pausing, and we said 15 minutes. If it is idle for 15 minutes, shut down the cluster, right? This is again we can change over here, right? So these are the settings that we can change. Likewise, on the left side you'll see a couple of other options. There is an options to kind of specify a file which will include all the packages that you want to install on the Spark cluster, which is being provisioned based on the Spark pool configuration. For now I'll keep it simple, and we'll go to the next section. I'll have a detailed coverage of this package management and library management in my future video. And the next option is again to specify the Spark configuration, right? So as I said earlier, it comes with the default configuration, but if you want to change it to something specific based on your requirement, you can change those by creating a text file, something like this, and changing the value and uploading this text file. So every time when a cluster is being provisioned from this Spark pool, it will use this config file to configure those parameters when the Spark session is being initialized. So this is how you can do it in Azure Portal. If we go to Synapse Studio and go to Manage Page or Manage tab on the left side, we can do pretty much same thing over here on this page again, assuming we have all the permission, all the required permission to kind of create a different type of analytical engine, in this case a Spark pool. You should be able to do the same from this place as well. So as you can see, all the pools that I had created earlier, it's already here. This one is the one that we just created from Azure Portal, and this is something available over here. Again, we'll see all the options. This is to kind of scale, change the scale setting. This is to change the pause setting, and there are a couple of other options over here, and those are again different parameters that we specified during the time when we created the Spark pool. If we want to change all those things, we can change it over here. So even after we have created the Spark pool, pretty much all the configuration, all the details you can change and apply it here. So this is a Spark pool that we just have created. Now since we have this Spark pool created, the next logical step is to kind of go ahead and start executing some code into it. To do that, click on Develop and go to the Develop tab over here. And as you can see, I have this notebook section over here under Develop. If you click on this, it will show me all the notebooks that I have created. And what I'm going to do is to demonstrate, I'm going to create a fresh notebook, and I'll say new notebook, and I'm going to specify a name over here. So demo script 1. I have demo script already, so I'll name it demo script 1. And the very first thing that I have to do is to kind of attach this notebook to a Spark pool against which this will get executed when I'm executing it, right? So to do that, click on this attach to option and select the Spark pool that we want to use to execute this notebook. So in this case, I'm going to use a Spark pool version 3.1. 3.1 is the Apache Spark version I included in the name, so that it becomes clear, but you are free to choose the name for your Spark pool based on your naming convention. So what I'm going to do here is, the very first thing is I'm going to use this piece of code, and what this piece of code is doing is basically it's taking New York LOTXI data from open data set for a specific period, in this case for a month data, and creating a data frame, right? In order to execute this code, there are multiple options, right? So we can click on this run cell icon, where in this case the code in this cell will start executing. Let me start executing, and then you can that's one of the options. The other option is to kind of hit shift enter, and that will start executing your code immediately. We are running this code for the very first time against the Spark pool that we have just created. So this is going to take, based on how frequently you start executing the code on the Spark pool, or whether the Spark pool, or there is already a cluster provision in that Spark pool. So this might take few seconds to a minute or two, right? So we are executing this for the very first time. So this first execution is going to take time. During that time, based on the configuration that we have specified with the Spark pool, the Spark cluster will get created, a Spark session will get initialized, and the code will start executing. So at this time, if you can see, the cluster has been created and the command is getting executed. This is something that you can see over here. This command is getting executed on the server for the very first time. And while it's running, you can also notice that there is a kind of combo box over here, and it says Apace Spark Python as a default language for the notebook, right? And that's where like I have written all this code in Apace Spark, right? If you have a code that you want to write it in, say, Scala or say a Spark SQL, if you want that language to be default for your notebook, you have to change it here. You can change it from this combo box. You can say a Spark SQL, Scala, or .NET. In that case, that will be the default language for the entire notebook. But in case if you want to mix and match for each of the cell, if it is different from the default language, you have to use the magic command, which will tell Spark that this is the language the code should be executed with, right? So in this case, it's a Python, so we have not specified over here. I'll show you some examples where we need to specify the language if we are kind of writing a set of a script which is not in the default language for the notebook, right? So at this time, if you see, the code has executed successfully, and we can expand this to see the job details and all those things. I will cover in a more details about how to monitor the execution of the job. But here are some of the options for you to start with. You can click on any of those links and you'll get more details about it. You can click on this view in monitoring, where you'll get the pictorial representation of how the execution actually started and what stages it went through. Or you can click on Open a Spark UI to look at the Spark UI, the standard Spark UI, for all the details related to execution of this job, right? So this is how you can monitor. I'll cover in detail in future video, but for now, let's go to the next section. So what I'm going to do is next is I clicked on that code plus code icon over here to create another cell in this notebook and write another set of command. At this time, I can minimize this properties page for my notebook, and I'm going to kind of run this command. What we did earlier was we created a data frame based on the data coming from the open data set, right? And what I'm going to do next is write that data of that data frame as a managed table in a Spark. But before that, I want to create a database with this name if it does not exist already, and create this table within that database, right? For that, let me kind of hit Shift Enter, and this will start executing the command in this window that I have. And while it's executing, let me kind of create another cell with new set of command, right? So here I have another cell, and at this time I want to execute a Spark SQL command. So %% is the magic command that we have to specify to change the default language specific to this cell. So in this case, this cell is going to contain Spark SQL command. So I'm saying %SQL, and I'm executing this command over here. Before I do that, let's wait for a few seconds for the previous command to get executed, so that the data which we are kind of reading from the open data set for a month and writing it as a managed table in the data lake storage account, the default data lake storage account, right? Now, based on how big that data set is, this process might take some time. In my case, the data volume is for a month, and it's almost completed now. So this is something that we can say it's completed now. And if we go and execute this command at this time, we are executing a Spark SQL command, and we should be able to see the results coming from the table that we have just created, right? And here it goes, right? So we can see tables getting created, and the data from that table is coming over here. Now, if you go to the data tab over here on this Synapse Studio, let me go to a different tab and open this data tab. And if I refresh this page just to make sure we are seeing the most recent data. So here on the data tab, we'll see an option for Lake database. So this is where you'll find all the Spark pool databases or Spark databases. This is the database that we created, NYC TLC tutorial. And if we click on this, we should be able to see the tables that we just created, right? So this is the table that we just created. Whatever table that we are creating in a Spark, it's also available from the data tab, and we can go and explore it from there. Now back to our original tab, right? So this is where we were. So one thing that if you notice here is by default this job got executed with one executor with 4 cores, right? And this is based on the type of workload that we are kind of executing, and based on the default configuration of Spark in Synapse. This is something gets decided, right? Now suppose we want to change this. We want to change this default configuration to something that is more relevant for our need, right? So one way is to kind of create a configuration file, upload it into the Spark pool, and every time any session is being initiated from that Spark pool, they'll have the configuration that has been defined for the Spark pool. So that's going to be for all the Spark session getting created within or from that Spark pool, right? So that's the one way to do it. The other way is, say for example, I want to change this configuration, but I don't want that to get applied to all the Spark session that's getting created, right? So I have one notebook which requires a different type of configuration, and I want to do that in a notebook itself. I don't want to do it at a Spark pool level, right? To do that, we can do that in the notebook by using the configure magic command. But before that, let me show you something. So here we have a spark.conf.get. So this is a method call or API call to get the configurable or configured value for this specific configuration key, right? So in this case, spark.driver.max results size, right? And if we execute this is going to give us the configuration for this specific key. I had one situation, and in this case, as you can see, this is 4 gig at this point in time, and I had one situation where like we were using Panda API, and the Panda API was kind of returning a data set which was larger than 4 gig, right? So we had to change that to a different value, right? We can do that, and to do that, this is what we use. We used configure command or configure magic command, and we said that this is my configuration key, and we want to set it to 10 gig. Let me execute this, and this is going to set the max result size to 10 gig. But make sure you have enough driver memory available if you are setting it to the specific value, right? Because the data set is being returned from all the nodes to the driver node. The driver node should have this much of memory available to accommodate it. Otherwise, you will have out of memory exception, right? So this is going to set that, and because I used -f in this case, so it's going to kind of apply this change as well as resetting the session, right? So this is going to take some time, and that's where it took 52 seconds to kind of apply this change and reset the settings. And if we go back and take this command again and execute it here, now we'll be able to see that new changes have been applied. And again, just to kind of reiterate, when you are changing this setting, make sure you have enough driver memory, otherwise you'll get out of memory exception. And you do this only in cases where you need more memory for the result set being returned to the driver node, like in the case of Panda's API, right? So this is one configuration change that I did, right? Now what I want to do is, like, if you go back to our previous discussion, right? So we had one executor with 4 core, right? And I want to change this default value, and I want to change it to something else, right? To do that, what I can do is I can take this value. Let me kind of paste it here. And before we change that value, let's see what's a default configuration for this configurable key, right? So we have executor.instances, executor.core, and executor.memory, right? So in this case, the executor.instance is 1, and that's why we see one instance was created. Executor.cores is 4. So in this case, each node is going to get 4 core, and memory is going to be 28 gig, right? I want to change this default behavior. I want to change it to something else. To do that, again, I can use configure magic command, and in this case, what I'm going to do is I'm going to specify the number of executors to be 4. Number of executor cores are going to be 4. So each executor will have 4 core, and executor memory is going to be 28 gig. If I don't specify, there is no harm. It's going to be the default one, but I have kept it here just for explaining the concept that, yeah, you can change the size, the memory getting allocated to the node as well, right? So let me execute this, and again, as I'm forcing for resetting the Spark session, it's going to take couple of seconds before it sets up this configuration and returns me the result. So at this time, the command has executed successfully and all the configuration changes has been applied. Let me go back and execute this command again and see if those are there. So once I execute this time I should be able to see those changes getting applied, right? So I had 4 instances with 4 cores and 28 gigs of memory. So those changes have been applied over here. Now, the one thing that you notice over here is, like, we created this notebook and we created multiple cells in this notebook, and each one has different type of command. You can mix and match based on the different language that you want to use, and you can set the default language. But at this time, this notebook is in my browser only. It's local to me. It's not saved somewhere, right? So to do that, I'll have to click on publish, and in this case, if you see here, this notebook is being saved as part of the Synapse service based on the Synapse Live configuration that we have over here. In case if you want to store this notebook as part of Git repository, then you can set that up over here, right? So you can click on this and you can set up a code repository where in that case, every time when you are saving this is going to be committed into the branch that you have set it up for this notebook. And I created a video. You can look at my last video with the title that Azure Synapse Analytics, continuous integration and continuous deployment, which has a step-by-step guide on how to set this up and how to kind of how to create the release pipeline to do deployment from one environment to other environment. So this is the notebook now published. So this button has grayed out now, and there are a couple of other things that you can notice over here. So if we go here, you see there is a comment section, right? So oftentimes we would be working in a team, and when someone is reviewing your code and wants to provide the feedback, the person can come here, select the piece of code that he or she wants to kind of provide the feedback on, and click on this new comment link to provide the feedback, right? Let's say review completed. I'm just giving a text message over here. Click on this and this will be saved as part of the notebook, and I can publish it. Again, it's zipped into the repository, in this case Synapse, as part of the Synapse service. But yeah, this is where reviewer can provide feedback, and someone who is kind of incorporating those feedback can have a look at those feedback and incorporate those feedback and mark it complete, right? So this is how we can annotate and comment on the code that we have written in this notebook, entire notebook. Now suppose we have created this notebook and we have all the codes written from end-to-end perspective, right? So whatever type of transformation that we want to apply, we have that in the notebook completed, right? And we want to execute all the cells in the notebook, right? So one way is to kind of open the notebook here in the Synapse Studio and click on run all, where it will start from executing from first cell till end of the cell, right? So this is one way to do it. The other way is to kind of create a pipeline and execute this notebook as part of the pipeline execution. So that way you can automate the execution of your notebook, right? I'll cover that in the next video, but yeah, that's an option available if you want to kind of automate the execution of the notebook. So far we created this notebook and we kind of added multiple cells with different command. If we come to this notebook section over here, there are a few things that you will notice, right? So if you click on these three dots over here, you can export this notebook to kind of move it from one environment to other environment, or to share it with other people, or you can clone this notebook in case if you want to create a copy and start making changes into that, or you can rename this notebook if you want to, right? Or you can move this notebook from this parent or root folder to a specific folder that you want to create, right? So if you come here, there are two options over here. One is to create a new notebook, and another one is to create new folder. Let me create a new folder, say examples, and move my at this time, if you see, I created this folder but I don't have anything inside this folder. Now what I want is, I want to move this file, which file or notebook which is sitting in the root folder, to the folder that I just created. So I can click on here, click on move item, and then I can select the folder where I want this to be moved and click on move, right? So this is going to be moved to the example folders that I just created, and I can publish it again to make sure my changes are saved, right? So this is how you can move it from one location to other location. You can simply drag and drop also, that also works fine. This is how you can get started with creating Spark pool, creating your notebook to start executing against a Spark pool that you have created. But if you are new to Synapse, we have a good collection of samples and examples to get started with. So let me click on this home, and if you go to the home of the Synapse Studio, you'll see there is a knowledge center option over here. Click on this link, right, and click on this browse gallery. At this time you'll see there is a tab here for notebooks. Click on notebooks, and now what you see is a different examples. There are some for data engineering type of workload, there are some for machine learning type of workload. Over here, these are some of the examples that's already there for you to kind of quickly get started. You, for example, look at this one, right? So create and manage a Spark table. So this is in Apace Spark. Create and manage a Spark table. If you want an example in a Scala, so this is in a Scala. Likewise, if you want to kind of build a regression model or kind of prediction model, there is an example here for Boston house price prediction, right? So these are some of the examples already available as part of the knowledge center for you to quickly get started. So this is one place to kind of get started with. Let me close this and go back to this screen, knowledge center homepage screen, and there is an option to create use sample immediately. Let me click on this, and this is a sample of different types of scenario, right? So what we are looking for is a sample for Spark. Click on explore sample data with Spark, and this comes with default sample Spark pool, and with this configuration. Click on this and say use sample. So this also is letting you know that this is going to be the default kind of or estimated charges for executing code against the Spark pool that we are creating per hour, right? So if we click on use sample, it's going to create the Spark pool as well as the notebook with all the details into it. So here we have the notebook that we just created using the samples, and what you can see here is like there are multiple sections in this notebook, right? And you can create this section by clicking on this plus markdown icon, right? So if you click on this, it's open up a text editor where you can specify the heading, right? So let's say this is heading 1, and we want to kind of make it, say, heading type 1. Heading 1 is going to be the bigger font than heading 2 and 3, right? So that's how the markdown is, right? So we can look at the definition over here. So this is how you can create a section in the notebook, and this notebook comes with multiple sections over here. The very first section is load data, and to have a quick look at what all sections this notebook has, you can click on this outline kind of link over here, and this is going to give you a very similar view as what we see in the Word document as navigation pane. So in this case, if you see here, load data is one section, analyze the NYC taxi data is another section. Clicking on this kind of link will take you to the respective section in the notebook, right? The final one is a cleanup resources. Clicking on this will take us to the section where we have the information about how to clean up the resources that we just created as part of the sample deployment, right? So these are some of the samples that comes already pre-installed or pre-configured. You just have to select and start using it, and yeah, it has pretty much all the details that you would need to kind of get started. With that, it's time to say goodbye again. In my next video, I'm going to get into details of Delta Table or Delta Lake and how you can use it effectively with Spark Pool in Synapse. Thank you once again for watching. Please do like, subscribe, and let me know your feedback or any specific topic you'd like me to cover next. Looking forward to seeing you all soon in the next video.